A and this angle subtended is given as phi. Okay. So to calculate field at point P due to this line charge, the resultant field will be somewhere down here, right? Resultant field, see, this is the charge, so net field will be somewhere along this, right? We have to calculate that. Okay, now next page will calculate this. By the way, this was problem number 5, right? This one was problem number 5. Due to the line charge, calculation of field at a point P. Okay. So here it is, x and a small length dx. Let's take this angle as theta. Okay, so the charge here, the charge dq in the small length is equal to lambda times dx, and the field will be this way, k lambda dx, kq by r square, right? So r means this is a, this is r, a sec theta, a sec theta square. This distance is equal to a sec theta, so a square sec square theta. Now we'll resolve it into two components and file the components separately. That's it. This is theta. Okay, so let's take this as y axis and this as the x axis, right? So this is k lambda dx by a square sec square theta times cos theta, and this will be a sine component, right? K lambda dx by a square sec square theta times sine theta. Now right, this ex. Okay, by the way, x also we can write x equal to a tan theta, so dx is a times sec square theta d theta. So this gets simplified dx. So by the way, so this is dex, right? Dex, and this is dey. Now the simplified terms, dey equal to k lambda dx. Dx will replace by this a square sec square theta, so it will be k lambda by a cos theta d theta, dex equal to, see, k lambda by a, again you substitute dx here, a sec square theta d theta, right? So here you get sin theta d theta. Okay, so what will be ey? This was the diagram. There you have theta, and this whole angle is phi. So this is theta equal to 0, 0, and this line corresponds to theta equal to phi. Okay, so ey equal to integral of k lambda by a cos theta d theta from 0 to phi, that is k lambda by a sin phi. Ex will be integral of k lambda by a sin theta d theta from again 0 to phi, so that's k lambda by a into integral sin theta d theta means minus cos theta, so it will be 1 minus cos phi. So these are the value of the fields along the x axis and the y axis. Now this question number 6, say again you have a line charge. You have a line charge and you have a point P here, so it's distance A, perpendicular distance A from the line charge, and it subtends angles like this, phi 1 here and phi 2 here. Right. Now we'll calculate the field at point P, and for that also you have to consider the x and the y components, right? Now suppose this is the red side, this is the red side, okay. For this side, what are the fields? K lambda by, let's take this page, k lambda by a sin phi, na? This component upward, y component, and this was k lambda by a 1 minus cos phi, okay. So we will use that formula. So this is k lambda by a sin phi 1, okay, and this will be k lambda by a 1 minus cos phi 1. Now this green side, let's take this green side, this is k lambda by a sin phi 2, and this is k lambda by a 1 minus cos phi 2, okay. So let's calculate the resultant field along these two directions. So this and this, so I will consider this as Ey and this is Ex. As we see, if you add up the fields, Ey is equal to k lambda by a sin phi 1 plus sin phi 2, Ex equal to this green one minus the red one, so that's k lambda by a cos phi 1 minus cos phi 2, right. So these are the formulas for calculating the field due to a line charge. Now we'll take up a special case for this line charge. Question number 7. Question number 7, the line charge will be infinite line charge. Lambda is the linear charge density. linear charge density means this charge by length. Okay, now at this point P, at a distance A, you have to calculate the field. For that, you know, phi 1 and phi 2, see, field Ey will be how much? Okay, what are the values of phi 1 and phi 2 here? Phi 1 and phi 2 both are equal to pi by 2. The end is very far away, so it is 90-degree angle and both sides. So it will be how much? K lambda by A, formula was sin phi 1 plus sin phi 2 means K lambda by A into sin pi by 2 plus sin pi by 2, that is 2 K lambda by A. If you substitute K is 1 by 4 pi epsilon naught, so it is lambda by 2 pi epsilon naught A. And obviously the x component of the field is 0 due to symmetry. Next, problem number 8, we will locate the neutral point. What is a neutral point? Neutral point means the point where the electric field E is equal to 0. In this case, locate the neutral point. This is Q and this is minus 4Q. See, if it were Q and plus 4Q, neutral point will be somewhere between, but here Q and minus Q, right? So added they are kept at a distance r. Now neutral point on this line, so if you take some point here between the charges, the say if you place a plus 1 charge here, Q will repel and minus 4Q will attract, so resultant field is towards the right, and here there is a chance, yes or no. If you keep a plus 1 charge here, this minus 4Q will attract, Q will repel. But the force due to minus 4Q is always stronger than the force due to Q. Why? Because that this is a smaller charge and the distance is large. So you get a neutral point at somewhere to the left. Say at some distance x to the left, you can get a neutral point. Why? Because due to Q, the charge, Q will repel and 4Q will attract. Now these forces can cancel to give a field 0. Now what about this force? This force is KQ by x square, and what about this force? This force is K 4Q, place a plus 1 charge force on that, 4Q by r plus x square. Now just equate this, implies I can do square root 1 by x equal to 2 by r plus x, implies x equal to r, that is at a distance r from charge Q to the left, you get a neutral point. Okay.